We're now going to talk about modules. Modules are a data type that contains multiple functions or methods that are meant to solve some specific problems. There are some modules that have a lot of functions related to statistics. There are some other modules that might have functions related to machine learning, or depending on the problem, you will find different modules. Let me give you a few examples. So if we want to import a module that has some math functions, the most common module is the math module. We can use the import math to basically import all of the functions that are found inside that module. And it's important to note that the word math is simply a label. If you think about it as if it were a name, that's Python variable name, that's the same thing. It just points at some object in memory that is the math module that contains those functions. We can check the type of the module math, and you will see that this is now a module. We can check which are the objects that are inside the math module. Some of the objects are methods, functions, and some other objects are just constants or attributes. We can use the dir function to tell us what are those objects that are held inside the math module, and you can see that many of them are just math functions. And again, there are some of this that are just attributes. So for example, if I take a look at the math.pi, that's an attribute, just basically holds the pi number in the math module. But you can see that there are also some functions or methods inside there. So we can see the square root, we can find something like the exponential, cosine, trigonometric functions in there. We can find more information about the module by using the dunder dict dunder. So let me give you an example. We can do math dunder dict, and basically what that tells you is a lot more information about whether whatever object inside there is a function or is something else. It might be useful in some cases. So for example, you can see that for example, the a cosine is a function, and you can see that the pi is an attribute. It's an attribute as opposed to a function. So that might be useful in some cases. We can find help of the module by just using the help function, and basically you can see information about each of the functions that is held inside the module. So you can see that all of this is laid out there. So that again might be helpful in some cases. So next we're going to talk about importing modules. And to import modules, there are many ways to do these, and we'll go about some of the most important or useful ones. We can use the import module name to import the whole module, that means all the functions inside. So for example, I can do import pandas, and that will import the whole pandas module. Now I can also use an alias, and basically an alias is just a name to remember. And for example, it's common not to import the pandas module just like this, but instead to use import pandas as PD. Now this PD is just an alias. It's just importing all of the functions found inside the pandas module, but now I can refer to that as PD. That might be because it's easier to write, it has fewer words, or you might remember it better. So just know that this is the most common convention, to use an alias. But that doesn't prevent you to, for example, just use, let's say, the module numpy, just import it like that, and every time you're going to use a function method or an attribute that is inside the NumPy module, you can just write the whole thing. Now, you can import also specific functions from a module. And let's suppose that because you imported the math module, you can say math square root, but you find yourself having to write this math module, the alias for the module that you wrote many times. So instead of doing that, you can use, for example, and say from the module math import the square root function. And what that will do is basically just import this particular function from the math module, and then it will hold the alias. This will be sort of an alias for the square root function, and it's pointing to where that function is located. So you can use square root of 9 as opposed to math dot square root. So that might be helpful in some cases. It is important to note that this doesn't give any specific advantage in terms of computational speed or anything like that. So in other words, the whole math module is imported in the inner workings of Python, so that doesn't provide any specific advantage in terms of how it runs or the speed that it runs. So it's useful to do something like that. So if you have you're having to use a lot of square root function from the math module, you just might import it like that, and that might be easier. If you want to import every single function from a module, you can do something like this. From math import and then asterisk, and what that will do is basically import to the current environment all the functions that are inside, or all the attributes that are inside there. So you can do something now like sign of, let's say, 0, and because you did from math import everything, then it's going to be just there without you having to just write math dot sign. So